Okay, so here's another example. The graph to the right shows potential energy in joules of a particle confined to the x-axis, right? So remember, we're thinking of this like a roller coaster, but there's no up and down to this. This is just something moving back and forth in a line, okay? Which points are stable and unstable equilibrium? Okay, so remember that wherever the slope is 0, we're looking for, okay? So stable, right, would be in the valley, so that would be at O and C. Okay, and unstable would be on the peaks or like the tops of the hill, which would be at point B. Okay, all right. If the particle is released from point O with a kinetic energy of 20 joules, okay, which of the following labels is a turning point? Okay, so remember, a turning point is going to happen when your kinetic energy is 0. Okay, because that would just think about the energy skate park guy. When he gets all the way to the top of the ramp as high as he can go, he's going to turn around, which means the velocity is going to be 0 there momentarily. Okay, so what we really want to look for is the total amount of energy. Okay, so that's going to be K plus U, and my total energy is going to be 20 joules. Okay, plus if I look at the graph, I can see that at this point I have 15 joules of potential energy. Okay, so that's going to give me a total energy of 35 joules to work with. All right, so if I think about on my graph, 35 is going to be my max out point, right? So I'm going to have this is going to be my E total line, so I can see E is going to be a turnaround point. Okay, because that's all the other values are able to get there, but once they get to point E, that's it. They're going to have to turn around. Okay, all right. See if the particle is released from rest at point E. Okay, right? Because remember, all the energy is potential at that point of whatever form. Okay, where is the kinetic energy a maximum? Okay, and what would be the speed at this point? All right, so you can see by looking at it, right? C has the lowest amount of potential energy, which means it's going to have the highest amount of kinetic energy. Okay, so I know if the total, okay, is 35 joules, all right, and I know C is going to have the least, let's say that is about 2.5 joules there, then I can see my kinetic energy at that point is going to be about 32.5 joules, okay, at that point, all right? And then all I have to do is just set that equal to 1/2 mv squared, and they give the mass as 3 kilograms, so 32.5 joules plus 1/2 times 3v squared, okay, and then you just have to do some math, okay? So these graphs aren't really that hard to read if you just don't really overthink it, okay? So that's going to be, I already took the square root, 4.7 about meters per second. Okay, right? So you can just find the different kinetic energies and potential energies at various points on here.